Hello, good morning everybody. Today we are going to solve exercises about lesson 4.5 where we reached, or actually some classes finished this lesson, but just in case. The exercises are page number 246 and 247. Um, Mainly 246 and 247. Exercise number 16 we will start. We have, as you see, part A, part B, part C. As we explained, it's a rational function. We are finding the limit at infinity, here at positive infinity, and sometimes it's going to be at negative infinity. First of all, as we explained, it's a rational function. We are going to start with the to write the term with the highest degree in the numerator. Okay, limit as x up. We have to keep on writing limit every time, as we are still writing x, as we are not still substituting. So up it's going to be 5x power 3 over 2, and in the denominator the highest degree is term is going to be 4x squared. Now as you can see here, the down is the denominator is the degree of the denominator is higher. Okay, so as we said in the explanation, it's going to be 0. But let's see together 5x power 3 over 2 and 4x power 2. If you subtract 2 minus 3 over 2, it's going to be half. Okay, we put it down because x power 2, degree 2 is higher. So 5 over 4, x power half. Now let's replace x by infinity. 4 times infinity, of course, it's going to be infinity. 5 over infinity, it's 0. As you know, as we explained, any number over infinity is going to be 0. Okay? Now the second example, here part B, limit, also the same. We are going to take the highest degree term here, and in the denominator the highest degree term, 5x power 3 over 2 and 4x power 3 over 2. The same degree, so we can cross out this and this together. The final answer is going to be 5 over 4. Okay, so this is the second case when we have the same degree up and down. It's going to be a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. Now let's go to the third example, part C, limit as x approaches infinity. Also we are going to take the highest degree term, and here the highest degree term, which is up it's 5x power 3 over 2, and down 4 radical x. Radical x, it's x power half, as you know. Okay, now as we did in the first one, okay, it's gonna be, we have to subtract the exponents. Power 3 over 2, 3 over 2 minus half, it's gonna be power 1. So 5 over 4 x power 1, which is, according to this infinity, 5 over 4 times infinity, which is infinity. Any number k times infinity is going to be infinity. But it depends on the sign of this infinity. If it's negative, it's going to be negative infinity. Or on the sign, also we have to take into consideration the sign of the number itself. Okay? So we have three cases, either 0 always, or a over b, or infinity. Okay, for rational function. Let's go to the second example. Exercise number 18. Okay, limit as x approaches negative infinity. Let's substitute directly 5 over negative infinity. Why you are here substituting directly? And here we don't have a rational. It's rational. It's rational, but every term is alone, so we can directly substitute it negative infinity over 3. So 5 over negative infinity, as we said, number over infinity is always 0. Now negative times negative, it's positive infinity over 3. Actually, infinity over any number is going to be infinity always. Okay, number 24. Limit of 6 over. Now let's here we can directly substitute, or we can change the exponent of x. If we are going to substitute directly, so we have to erase the limit and no need to write it. Okay, 5 plus 2 e power negative 4 times infinity. Okay, 6 over 5 plus 2 e power negative infinity. Okay, to avoid writing many steps, e power negative infinity. You know, let's write it, no problem. e power negative infinity. We can now e power negative infinity, you know, any number power negative exponent, we can put it in the denominator. So it's going to be e power infinity. Number over e power infinity. So 6 over 5 plus 2 over infinity. 2 over infinity is going to be 0. So it's going to be 6 over 5 plus 2 over infinity, which is 0. So the final answer is going to be 6 over 5. Okay? Now, I think this is number 26. This is number 26. It's going to be, here when we have radicals, okay? First of all, let's write the upper one, which is x. What's the highest term here inside the radical? X squared or 1? Of course, it's x squared. So I'm going to write it as radical x squared. Limit as x approaches, we have to keep on writing limit every time. Okay, just here I'm not writing. When I replace here in this example, I'm not writing. When I replace the number itself directly, so no need to write limits. Now this is again limit as x approaches negative infinity. Every time you have radical x squared, as you know from grade 9, it's going to be absolute x. Okay, now how we are going to get rid of this absolute symbol? At negative infinity, it's a negative number. As you know, that absolute x, it's either positive x or negative x, according to what? According to x itself. So as x approaches negative infinity, I'm going to write it as negative x. Okay? Now, limit as x approaches negative infinity, x over x is nothing. It's 1. It's 1. So 1 over negative 1, the answer is negative 1. Okay? What if it was here, it's infinity? So I'm going to take absolute x as what? Yes, as x itself. Now let's move to the next exercise, number 32. Okay, here the highest up I have actually one term, so I'm going to write it as 2x. Don't forget to write limit every time. Okay, and here x power 6 and minus 1, the highest term is x power 6, of course, and I have power 1 over 3. Okay, 2x over x power 6. Here we have to multiply the exponents. 6 times 1 over 3, it's going to be 2. Yes. So limit as x approaches negative infinity. Now subtract. This is here nothing. It means I have exponent 1. Subtract. It's going to be 2 over x power 2 minus 1. It's 1, of course. So as x approaches to negative infinity, the final answer now is going to be 2 over negative infinity, which is 0. Yes. Number 41. Number 41, we can directly substitute it directly. 8, let's try to write it as 8 over t minus arc tan t as t goes to infinity. Now, let's substitute now 8 over infinity, which is going to be 0, yes, minus arc tan infinity. Here, arc tan infinity, my students ask me about it. How do we know, yeah, Mr. Arc tan infinity? We have many angles. Its tan is, its arc tan is infinity. I mean, we have many angles. The tan is going to be infinity, like tan pi over 2, tan 3 pi over 5 pi over 2, and so on. Actually, I'm not going to go to grade 11 to see the domain and the range, talk about it. But we can, in this case, if you know it, directly you can say it's pi over 2. Or you can go back and graph it using the graphical calculator. I'm going to show you now using the graphical calculator. But let's finish here this one. 8 over infinity is going to be 0. 0 minus pi over 2, it's negative pi over 2. This is the final answer. Well, actually, guys, every time, check your answer using graphical calculator. Let's see. This is, let's write the function. Let's write the function. 8 x exponent negative 1, or you can write it as 8x over 8 over x plus arc tan, it's shift tan, x. Okay, now let's graph it. As you can see, it's approaching at as x approaching infinity, it's approaching a certain number. Okay, how can we know this number? We can go and see at the y-axis. If we can graph it, we can see it's gonna be here approaching something which is 1 point something between 1 and 2, and 1 point between 1 and 2. There's only one value which is pi over 2 that we know, and its tan is gonna be infinity. Okay, or simply you can say go to the graph menu 1 and let's delete all of these. Shift tan, okay, or tan pi over 2. It's gonna give us a math error which is infinity. Okay, or again to the graph it again. You can say, let's say trace and choose any value you want. Infinity means choose any large value. Okay, let's say take 5 for example. Here it's not that large. To make it large, we can change the view window from 0 till maximum. We can take it to make it very large to 50. Okay, now graph it again. Choose any value. Press F1 to trace, and then choose now, let's say 49, because our view window is going to be you see now it's going to be 1.7. It's approaching to 1.5, approaching 1.57, closer and closer to 1.57, which we know it's going to be pi over 2. Okay, so in general we know that arctan infinity, it's going to be a odd multiple of pi over 2. In this case it's pi over 2. Okay, لانه arctan its range is going to be between negative pi over 2 and pi over 2. And يعني this is I'm trying to make it as easy as I can. Now you can directly write it as pi over 2 whenever you see arctan infinity. Okay, now number 43. Now we finished limits actually. The question here is saying just this is the function. It's absolute x over x plus 1. Find the horizontal asymptotes. Okay, the question is not saying find the limit, but when the question is saying find the horizontal asymptotes, we should know directly that we have to find the limit of f of x at negative infinity and the limit of f of x at positive infinity. Okay, as you know that if the limit gives us a number, a constant number, then y equals this number is going to be the horizontal asymptote. Okay, so limit here of absolute x over x plus 1 as x approaches negative infinity. Okay, it's going to be equal. Here up, it's only one term, which is absolute. Down we have x and 1. As we said, we take the highest one, which is x. As x approaches negative infinity, how do we get rid of this absolute value? Yes, negative x over x, and we still write here limit as x approaches negative infinity. Now negative x over x, as you know, it's going to be negative 1. So y equals negative 1 is the first horizontal asymptote. Let's see if at infinity we are going to see the same asymptote or a different one. It's limit of absolute x over x plus 1 as x approaches infinity. The highest one here is absolute. I don't have any other term. And down it's x only. As x approaches infinity, it's going to be x, not negative x, and it's positive over x. So it's going to be 1. Okay, so y here, y equals 1 is another horizontal asymptote. Okay, we said some functions may have 2 horizontal asymptotes, some 1, and we may have no horizontal asymptotes. But in which cases? In this case, absolute x. Okay, and if we have, for example, any other case like this one, like if we have radical x squared plus minus 5, let's say, over absolute also, or I mean over x plus 1 also. So also this one we have 2 horizontal asymptotes. In these two cases, when we have radical, even radical actually of x power 2, whatever, and so on, and absolute, in these two cases we have 2 horizontal asymptotes. Now the last part of the lesson, which is the last exercise, in this case we don't have a rational function. In this case we have a function containing polynomial plus radical or minus radical. In this case, if we are going to substitute directly, 4 times infinity is going to be infinity minus radical, it's always positive, and radical is going to be here infinity. Infinity minus infinity, it's one of the indeterminate forms, as you know. We have many indeterminate forms. Actually, we have 0 over 0 as we took in the beginning of the year, 0 over 0. And if we have infinity over infinity, also infinity minus infinity is one of the indeterminate forms. Anyway, now how we are going to find this limit? Actually, since we have radical, so we can, yes, we can multiply it by its conjugate, which we call rationalize here the numerator, لأنه it's up, so here over 1. Actually, the book is saying rationalize it, but we should know it without asking us, and we have to know that we have to rationalize, multiply by the conjugate, which is here 4x plus radical 16x squared minus x over 4x plus radical 16x squared minus x. Now, limit as x approaches infinity, it's going to be what? Here, the denominator 1 times this, we can rewrite it again, just 4x plus radical 16x squared minus x. For the upper, which is the numerator, it's a minus b into a plus b, as you know, which is going to be a squared minus b squared. So 4x squared minus radical, let's write it directly. 4x squared, which is 16x squared, minus radical squared, which is 16x squared minus x. And now, let's distribute to simplify. It's going to be 16x squared minus 16x squared plus x over 4x plus radical 16x squared minus x. Of course, I'm going to write limit again for every step. 16x squared minus 16x squared, let's cross them. Now, let's continue here. It's going to be limit as x approaches infinity. Up I have x plus 4x plus. Now here, the highest one is, yes, radical 16x squared at infinity. No need to write this again. Okay? How do we get rid of this radical? Radical 4x here. Radical 16x squared, it's actually, as we said, radical x squared is going to be absolute x. So here it's going to be absolute. Radical 16, it's 4. Absolute x squared, x. Okay? Now, let's continue. It's going to be equal to limit as x approaches infinity, x over 4x. Here, are we going to write it as 4x or negative 4x? Yes, x is going to positive infinity, so it's positive. So we write it as 4x. Now, the final answer down is going to be 4x plus 4x, which is 8x as x approaches infinity, which is going to be x will be crossed with x. So it's 1 over 8. This is the final answer. And this is the last question in lesson 4.5. I hope you understood everything. And next video is going to be to explanation about lesson 4.6, inshallah. God bless you all and goodbye.